solving our trig equations. So what's really important now is to have a look at how they specify the domain. Okay, so where we're solving it. Do they want their answers in degrees? Do they want their answers in radians? So we're going to match what they ask for. So if they say it's between 0 and 2 pi, it would be incorrect to give the answers in degrees. They want the answer in radians. So reasonably straightforward. And here, 2 sine x is minus root 3. So we get minus root 3 on 2. So okay, third and fourth quadrants. I'll just draw my little picture up there. Whee! There you go. Third and fourth quadrants. We know the acute angle. Now, it's not 60 degrees. It's pi on 3 radians. So now, in the third quadrant, instead of saying 180 plus the acute angle, it would be pi plus the acute angle. And in the fourth quadrant, it would be 2 pi minus the acute angle. And we get 4 pi on 3 and 5 pi on 3. Okay, tan squared is equal to 3. Again, a reasonably straightforward one, but remember, plus or minus. So actually we're in all 4 quadrants for this one. All 4. So we get to draw, oh look, a butterfly. There we go. So the acute angle would be pi on 3 again. But we'd end up with 4 answers when we sub it in. Pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3. Cos squared plus cos. So factorise, we get 2 possibilities there. Either cos is negative 2, cos is 1. Now, let's deal with each of these. Cos is negative 2. Well, that's a nice easy one to solve, because it can never be negative 2. Cos, remember, goes in between minus 1 and 1. So there's no solutions to that part. Cos is 1. Again, if you think of your curve, it's a boundary value because cos, the amplitude of cos is 1. So let's think of the picture. When did it starts at 1, doesn't it, cos? So it would be 0, but that of course means 2 pi as well. Don't get caught out with that. Whenever 0 is a solution, 2 pi is going to be a solution as well, because it's the same point basically. Here's one where we use our trig identities. So we change our sec squared to be 1 plus tan squared. And again, we get a quadratic, factorises nicely. So tan's negative 1/4 or 1. This one's going to have a bit more work involved. So let's do the negative 1/4, second quadrant or fourth quadrant. The acute angle is 1/4. I've gone for a decimal approximation there because obviously it's not an exact value. So I've just done 3 decimal places. And remember, make sure, oh yes, make sure if it's not an exact value and you go into your calculator, make sure your calculator is in radians. Okay, so you get your 0.245. And then on the other side, that is an exact value, so that's a bit easier. We get pi on 4 for the acute angle. Putting it all together, there's our 4 possibilities. Sine 2x. Okay, there's different ways of solving this one. The quickest way is probably to go, well, all right, let's just solve it for 2x first of all. But if x is going between 0 and 2 pi, 2x must be going between 0 and 4 pi. So we've got to go round the circle twice looking for answers. We're in quadrant 1 and quadrant 2. The acute angle ends up being pi and 4. So in quadrant 1 and quadrant 2, we get pi and 4 and 3 pi and 4, but we're going around the circle twice. So we add, well, if it was in degrees, we would have added 360 to both solutions. But we're in radians, so we'll add 2 pi to both solutions. And we get 9 pi on 4 and 11 pi on 4. That's what 2x is. Divide everything by 2, and it should bring all those answers back to being between 0 and 2 pi. Alrighty. Let's add those to our list. 11 each.